Hello, good morning, good afternoon, everyone.
Good afternoon, madam.
Hello,
Good
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 afternoon,
afternoon,
madam.
afternoon.
everyone.
Okay, can you hear me clearly?
Yes,
Welcome, madam.
please.
Okay. And can you see the slides on your screen?
Yes.
Okay. Thank you. Okay, so shall we start at 1 5?
Madam, please, what did you say?
Shall we start? Or I can see, yeah, it's 10.
Yeah, we can start. We can
Oh,
start.
okay. Okay, yes. So, from our last lecture, I understand that we need a bit of a brush up. So, I have put together a full revision of Java programming. Okay, so I have kept it focused. So, only the topics that really matter as a foundation for our advanced Java work coming up. Okay, and now last week I shared the module notes and slides and some links with you to go through the basics of Java on your own. Have you all gone through it?
No, madam.
Okay. Okay, so okay, then we'll start with the basics of Java programming. It's just for, there are some things that we need to clear it before going to advanced Java. Okay, so I'll repeat this because it matters. Just listening in class is not enough to learn programming. You have to practice and revise on your own too. And a clear understanding of Java fundamentals is very important before moving on to advanced topics. So, therefore, today's class will focus entirely on revision, and this will help you identify any areas where you need more practice or more understanding. Okay. And I also hope that everyone has installed IntelliJ by now. So before we begin the practical exercises, there are a few important topics I need to review with you first. Okay, so let's get started. Yes. So before we begin, let's quickly look at what we will cover today so that you have a clear idea of the session. So we have 12 topics to revise, and I have grouped them into 3 main sessions. The first section covers the foundation of Java programming. This includes an introduction to Java, the basic concept of object-oriented programming, variables and constants, the structure of a Java program, and the main method. And the second section focuses on making programs perform tasks. So we will look at operators, how to receive input from users, and how to display output. And the third section covers program control and data handling. So this includes decision making statements, loops, arrays, and methods. So most of these topics should already be familiar to you. Okay, so Okay. So if you did not fully review the last week materials, some concept may still seem new. So that is perfectly fine because today's session is designed to refresh your understanding and strengthen your knowledge of the basics. Okay. So let's start with our first topic, that is Introduction to Java. So Java is a high-level object-oriented and platform-independent programming language. It was developed by James Gosling and Sun Microsystem and was first released in 1995. Even today, Java remains one of the most popular programming languages in the world. So one of the most famous features is its slogan, write once, run anywhere. So this means a Java program can run on different operating systems without needing to be rewritten. So how does this work? So when you write a Java program, you save it as a .java file. The Java compiler then converts the source code into bytecode, which is stored in a .class file. So this bytecode is not directly executed by the operating system. Instead, it is executed by the JVM. So JVM is available for different operating systems such as Windows, Linux, and Mac OS. Although each operating system has its own JVM, the bytecode remains the same. So that is why the same Java program can run on different platforms without modifications. So Java is also a strongly typed language. So this means that every variable must have a specific data type, such as int, double, or string, before it can be used. And another important feature of Java is automatic memory management. So Java uses a process called garbage collection to automatically remove unused objects from memory. So unlike languages such as C or C++, programmers do not need to manually free memory, making Java programs easier and safer to manage. And Java is used to build Android apps, web apps, enterprise softwares, and more. Yes, are you getting? Am I going fast?
Madam, please, we are getting you.
Okay, okay. And next is object-oriented programming. So Java is an object-oriented programming languages. So object-oriented programming means it's a way of designing and organizing programs using objects and classes. So it helps programmers create software that is easier to understand, manage, and maintain. So there are four main pillars of object-oriented programming that every Java programmer should know. What are they? They are encapsulation, inheritance, polymorphism, and abstraction. Yes, can anyone explain me this four pillars of object-oriented programming? Any idea? Yes? Okay. Then I'll explain it. So encapsulation. Encapsulation means keeping data and methods that control it together while hiding the internal details from user. So think about the electrical switchboard in a classroom. Okay. So when you want to turn on a light or a fan, you simply press the switch. So the switchboard provides an easy way to control the electrical system. However, you don't see or touch the electrical wires behind the wall. The complex wires are hidden and protected inside the wall, while the switch is provided for safe access. Okay, so in this example, the wires and electrical connections are hidden, and the switch is the only thing the user can access. So the user can control the light or fan without knowing how the wiring works. So this is exactly how encapsulation works in programming. Important data is hidden and protected, while specific methods are provided to access or modify the data safely. So the key idea is hide the internal details and provide a safe way for users to interact with the system. Okay, so encapsulation is the process of hiding internal details and allowing access only through controlled methods. Okay, and next we have inheritance. So, inheritance means one class can acquire the features and behavior of another class. So, in real life, children inherit characteristics from their parents. For example, another example I can give a dog. A dog is an animal, a car is a vehicle, a student is a person. Yes, the child can use features that already exist in the parent instead of creating everything from the beginning. So, the key idea is reuse existing features and avoid repeating work. That is inheritance. And the third one is polymorphism. It means one thing can take many forms. For example, the word run, RUN, run. Okay, it can have different meanings depending on the situation. So a person can run, a machine can run, yes, a computer program can run. The same action can behave differently depending on the object involved. One action can produce different results in different situations. That is polymorphism. Okay, and the last one is abstraction. So we have already seen the example, the switchboard example. Yes, so let's use the same example to understand abstraction. So when you want to switch on the light, you simply press the switch. So do you need to know how the electrical wires are connected or how electricity flows through the circuit or how the switch controls the light or fan? No. You only need to know which switch to press to get the result you want. The complex electrical system is hidden from you, and only the necessary controls are shown. So, this is called abstraction. So, abstraction is the process of hiding complex implementation details and showing only the essential features to the user. Okay, so are you getting?
Madam, can you go over the abstraction again, please?
Okay. So abstraction is the process of hiding complex implementation. So in the example, we um, we need to switch on the light. So we don't have to bother about how electrical wires are connected, how electricity is flowing through. You don't need those informations. You only need to know which switch to press to get the result you want. So the complex system is hidden from you and only the necessary controls are shown. So in the switchboard example, you see the switch and you use the switch. So you don't see or need to understand the internal electrical system. So abstraction makes systems easier to use because users can focus on what to do rather than how it works internally. So in encapsulation, the wires and electrical connections are hidden and protected. So encapsulation focuses on data hiding, means protecting our data. And the abstraction, the user only needs to know how to use the switch, not the system, how the electrical system works. So that is the difference between encapsulation and abstraction. Yes, is this clear? Any question?
No, please.
Okay. So this is very important in object-oriented programming. So if you take any object-oriented language, this remains same. Okay. So next, the next topic is variables and data types. So a variable is simply a named storage location in memory that is used to store data. So think of a variable as a labeled container or box. So you can put information inside the box, use it when needed, and even change its contents later. For example, imagine you have a box labeled student name. So inside that box, you can store the name of a student. And you have another box that is labeled as student age, which stores the student's age. So in programming, variables work in exactly the same way. So programs need to store information so that they can process it later. For example, a school management system may need to store the name of the student, the index number, age, marks. So instead of typing these values repeatedly, we store them in variables. Okay, so Java is a strongly typed language. That is, in Java, before creating a variable, we must specify the type of data it will store. So that is why Java is called a strongly typed language. For example, if you are trying to store the age of a student, so it should be stored as an integer number. It's a value. And then a student's name should be stored as text. So the data type will be string. So Java needs to know the type of data before storing it. And these are the available data types. We have byte, int, long, float, double, character, boolean. And this is the size, and this is how we declare in Java. We declare and initialize. Okay. And this is another example where I'm going to store the marks. So I declared it, I mentioned the type, then the variable name, and the value, I'm initializing it. Okay. Next, we have constants. So we have already learned that a variable is a storage location whose value can change during program execution. But sometimes we have values that should never change. For such values, we use constants. Constants, okay. So a constant is simply a variable whose value remains fixed throughout the program. So think about the number of days in a week. There are always 7 days in a week. So this value does not change from one day to another. So similarly, the value of pi is approximately 3.14. And the number of month in a year is 12. So since these values do not change, they are the good examples of constants. Okay. Any question?
No, please.
No, please.
Okay. So you'll know how to create a constant. Yes, so we use the keyword final. So you can see this example. So when a variable is declared as final, its value can be assigned only once. And after that, the value cannot be changed. That's why you can see a cross mark here. That is compile error. Okay, so I'm not going into deep because we have limited time. So you once I come, okay, let me complete this. Okay, so here next we have the structure of a Java program. So think of a Java program like a house. So just as a house has different parts such as roof, wall, doors, and rooms, Java program also has different sections that work together. So here you can see a simple Java program that is divided into 5 main parts. So the first part, the first one is a package statement. So a package is used to organize related classes into groups. So you can think of a package as a folder on your computer that stores related files together. For example, student related classes can be placed in one package, and library related classes can be placed in another package. So here the package statement is optional, especially in simple beginner programs. So package helps keep program organized. Okay. And the next one we have import statement. The Java provides many pre-written classes that programmers can use instead of creating everything from scratch. So when we need to use one of these classes, we import it into our program. For example, if we want to receive input from the keyboard, so we often use the scanner class, which must be imported first. See here, import java.util.scanner. So import statements allow us to use Java's built-in classes. And the third one is a class declaration. So every Java program must be written inside a class. So you can think of a class as a container that holds a program's code. So without a class, Java cannot run a program. So this is one of the most important rules in Java. Every Java program must contain at least one class. So a class is a main container for Java code. And the next one is a main method. The main method is known as the entry point of a Java program. So when a program starts, the JVM, Java Virtual Machine, looks for the main method first. The JVM begins executing the program from this method. So think of the main method as a front door of a house. So if someone wants to enter the house, they use the front door. Similarly, when Java wants to start a program, it enters through the main method. So here, this is a main method, public static void main. So program execution starts from the main method. And the fifth one, the last one, is a statements and comments. So inside the main method, we write our instructions. So these instructions are called statements. So statements tell the computer what action to perform. For example, display a message, or calculate a result, or receive user input. And we can also write comments. So comments are notes written by programmers to explain the code. So comments help make programs easier to understand and maintain. The Java ignores comments when running the program. Okay, so statements are instructions for the computer, while comments are notes for people. Okay, next moving to the main method. Yes. So we learned that the main method is a starting point of a Java program. So whenever a Java program runs, the JVM looks for the main method and starts executing the program from there. The main method has a special format called a method signature. So that is public static void main string arguments. So many students memorize this line without understanding. So let's break it down and understand what each word means. So think of this as 5 separate parts working together. Okay. So first one is public. The keyword public means the method can be accessed from anywhere. So when a Java program starts, the JVM needs to call the main method. Since the JVM is outside our class, the method must be accessible to it. That is why we use public. The simple meaning is anyone who needs to access this method is allowed to do so. So that is public. And the next one is static. This is usually the most difficult keyword for beginners to understand. To use a normal method, Java first needs to create an object of the class. But when a program starts, no object have been created yet. So the JVM needs to run the main method immediately. So making the method static allows the JVM to call it directly through the class without creating an object first. So in the last class, we have already discussed about static methods. We have done some examples. Yes, you remember? Yes, is everyone still here or am I talking to myself?
We are still
Yeah,
here.
we are here.
Yeah.
Okay, okay. So I'll give you a simple example. Imagine a notice board. Okay, so you can read the information directly from the board without creating a copy of the board for yourself, right? So similarly, a static method belongs to the class itself and can be used directly. You're getting the difference between a normal method and a static method? Are you getting?
Yes, madam.
Okay, yes. And next is the void keyword. So the keyword void means the method does not return any value. So some methods performs a task and sends the result back. And the main method simply starts the program and performs its task. So it does not send any value back to the JVM. So this method does not return anything. And the word main is the name of the method. So this name is special because the JVM is programmed to look specifically for a method called main. So if we change the name to something else, the JVM will not recognize it as a starting point of the program. So this is the official starting method of every Java application. And the last one is string arguments. So this part allows the program to receive information when it starts. So string means string, you can see a bracket here. So that means an array of text values. An argument, args is the name of the array. So for beginners, think of it as a container that can hold information provided when the program is launched. So most beginner programs do not use command line arguments. So but the parameter must still be present in the main method signature. So it's a place to receive information when program starts. Okay, so you're getting what is public static void main?
Yes, madam.
Okay. Okay. So next is, so we have already discussed this. Why is main static? Yes, so we know that every Java program starts from the main method. So when you run a Java program, the JVM loads a class and immediately looks for the main method. So at this point, no object of the class has been created yet. So JVM simply knows I need to find the main method and start executing the program. So what happens if main was not static? What will happen? So remember that a non-static method belongs to an object. So before calling a non-static method, Java must first create an object. So now imagine that the main method, for example, I'm creating a class student. So after creating the class, I need to create the object. So I'll write student s equal to new student. And if I have non-static methods, then I'll use the object s dot display. Display is a method. So here the object s must exist before the method display can be called. So now imagine that the main method was not static. The JVM would not, the JVM would need to create an object before calling main. Then there will be another question. So which constructor should be used and what value should be passed to the constructor? How should the object be created? So JVM does not know the answers of these questions. So this creates a chicken and egg problem. Okay, so to run the program, JVM needs to call main. So to call main, it first needs an object. So to create the object, it may need instructions from the program. But the program has not started yet because the main has not been called. So the JVM get stuck. So this will be the problem if we don't declare our main method as static. So a static method belongs to the class itself, not to an object. So JVM can call the method directly using the class name. Okay. And next we have operators. So you are already very familiar with this topic. So I don't think I need to spend much time explaining it. Yes. So can I go to the next topic?
Yes, madam.
Yes. So we have arithmetic and assignment operators, relational and logical operators, increment and decrement operators. Okay. And next we have how to take input from the user. Most programs need information from the user. So in Java, we use the scanner class to read input from the keyboard. So first, we import the scanner class, that is import java.util.scanner. Then we create a scanner object. See, inside the main, we create the scanner object. And here, then we are printing a message, enter your name. And then you will enter the name and it will get stored in the variable name. And same way, you are printing a message, enter your age, and it will get stored in the variable age. And it is good practice to close the scanner, that is sc.close. Okay, so this is how we take input from the user. And then we have some commonly used methods, that is next int, next double, next line. So next int reads an integer and next double reads a decimal number and next line reads a complete line of text. So remember, next line reads everything on the line, including spaces. Okay. And the next is printing the output. So displaying output is something you have already done many times. So this should be straightforward. So Java provides three common methods for displaying output to the console. We have print, println, printf. So print is display text and stays on the same line, and println displays text and moves to the next line. Okay, and printf display formatted output. Okay. And for formatted output, we use printf. So you can use the /d, this one, %d. Then you can use %s for string and %2f for float values, decimal values. Okay, so these three methods are the most commonly used ways to display output in Java programs. Okay. And next we have decision-making statements. So decision-making is one of the most important parts of programming. So in Java, we use if else, if else, and switch case. Yes, so if executes a block of code when condition is true. And we have if else. So if the condition is true, it executes the first block of statement. Otherwise, it executes the second block of, that is the else part. And then we have if else if. Okay, so Java evaluate conditions from top to bottom and stops as soon as it finds the first condition that is true. Okay. So please, you practice some examples, some simple examples of decision-making statements, because we need these all things in our advanced Java. And then we have switch statement. So it is often used instead of a long if-else chain. So when we are comparing one variable against multiple fixed values, okay, so as a switch statement contain case, break, default. I think you all know it. Do I need to explain it? Yes.
Madam, please, can you come again? The question again.
So you have done practicals on switch cases, decision-making statements, right? In Java programming or C++.
No, madam.
In C++ also you have not done switch. Hey, then see, that's why I shared your link last week. See, please, these are the basics. You have to find out time and you have to revise it. Yes, so the switch has when you wanted to compare one variable with multiple fixed values. So here in this example, I have a variable day. I'm initializing it 3. So this is a syntax. This is a structure of a switch case. Switch and your variable. And you will have cases. So case specific values to check. And break stops execution after a match is found. And default is, the last one is a default. So runs if no case matches. So in this example, the day is 3. So Java checks the case one by one. First it checks case 1. No, it's not matching. Then it checks case 2. Then again it is not matching. Then case 3. So 3 equal to 3. Yes. So Java displays Wednesday on the screen. And the break statement then stops the switch statement immediately. So when you get the output Wednesday, when it prints, it will execute the break. So it will come out of the switch. Means here is the closing of the switch. You can see the small curly bracket. So this is where we are closing the switch. So if we get a match, then it print the output, it executes a break, it directly come out of the switch. It's not going to check the next case. Okay, so without break, Java would continue executing the next cases as well. So this is called fall through and is a common mistake for beginners. So don't forget to write the break. So use switch case when checking one variable against several fixed values. And always remember the break statement. Okay, and default works like the final else block in an if-else statement. Okay. So please, you will get video tutorials and everything for your Java program basics. These are the basics. I'm not even started with the advanced Java. So I wanted to cover the basics. So please go through it. And another important thing is loops. So far, programs have executed statements one by one. Yes. So, but what if we want to perform the same task multiple times? So instead of writing the same code repeatedly, we use loops. So a loop is a programming structure that allows a block of code to execute repeatedly until a condition is met. So Java provides several types of loops, and the most commonly used one is a for loop. So for loop is used when we know in advance how many times we want to repeat a task. So a for loop has three parts: initialization, condition. Mhm. Initialization. Just.
Madam, your screen went off and we can't hear you. Guys, can you hear? I'm the only one.
It's all of us.
Okay.
Hello. Can you hear me?
Yes, madam.
Okay. Hello. Hello. Okay. Hello, can you hear me?
Yes,
Yes,
madam.
madam.
Please
But
hear you, but
it's
your
only
voice
there.
is echoing.
But I can't see your screen. Is it only me?
Yeah, your screen too is off.
Okay. Please, can you mute your mics? I'm hearing my voice.
Yes, madam. We can hear you by your screen.
Okay, just give me a second. Can you see the slides?
Yes, but your voice is echoing.
Oh, just a minute. Yes, hello. Can you hear me?
Yes, we can.
Clear?
Yes.
Yeah, I can hear you.
Okay, okay. Okay. So, yes, so for loop, we have three parts. That is initialization, that runs once at the beginning. And then we have the condition checked before every iteration. And then update, that is increment or decrement. So that runs after each iteration. So, for example, if you are trying to print 1 to 5 numbers, so you will start from 1 and you will enter 5. So, the first step is initialization. So, you are printing integer numbers. So, I'm taking the data type as int I equal to 1, starting from 1. And my condition will be when it reaches 5, it should stop. So I less than or equal to 5. And then every step, like after printing the number, it should increment. First, it will print 1, then it should increment to 2, then 3, then 4. So I'm using I plus plus. And I'm simply printing it on the screen, that is system.out.println. So I'll get this output 1, 2, 3, 4. Okay, so the variable I starts at 1, increases by 1 after each iteration, and stops when the condition becomes false. So another common use of for loop is performing calculations repeatedly, such as finding the sum of numbers from 1 to 100. So in this example, I'm finding the sum of numbers from 1 to 100. So I'm initializing it as I equal to 1 because starting from 1 and my condition is I less than or equal to 100. So sum is equal to sum plus I. So this is the short form. So instead of writing sum is equal to sum plus I, you can write sum plus equal to I. Okay. So a loop repeats a block of code, and a for loop is the best choice when you know how many times a repetition should occur. And we have while and do while loops. So we use while and do while loops when we do not know in advance how many times a task needs to be repeated. So a while loop checks the condition first. The first one is a while and this is a do while. So a while loop checks the condition first, and if the condition is false from the beginning, the loop will not execute at all. And then do while loop executes the code first and then checks the condition. So this means the loop body will always run at least once. So here we are declaring it I equal to 1. Then we are not checking at the beginning. We are performing the action and at the end we are checking it. The condition is I less than or equal to 5. So the main difference between while and do while is while check the condition first. So here, see the condition is we are writing it first and then execution. But in do while, execution first and then condition. Okay, and then we use some keywords break and continue. So break means immediately exit the loop. We write the break. And continue means skips the rest of the current iteration and moves to the next. So if you are trying to print 1 to 10, and in 1 to 10 you don't want to print 5. Okay, so in that case you can write if I equal to 5, continue. So instead of printing the value that is 5, it will directly jump to the next iteration, that is 6. So continue skips the rest of the current iteration and move to the next iteration. Okay. And then we have arrays. So sometimes we need to store multiple values of the same type. So instead of creating many separate variables, we can use an array. An array is a collection of values of the same data type stored under a single variable name. So we can create an array with the fixed size. So that is the first one, data type. You can write int marks equal to new int of 5. Or we can directly initialize the array values. Okay, so think of an array as a row of boxes where each box stores one value. So one important thing to remember is that array index starts from 0, not from 1. So in this example, see, it starts from 0, 1, 2, 3, 4. But total, I'm going to store 5 values. So array length is, the length of the array is 5. So array stores multiple values of the same type. And array indexing starts at 0. And you can use array dot length, array name dot length to find the number of elements in the array. Yes. And then we have 2D array. So we have looked at one-dimensional array which stores values in a single row. And sometimes we need to store in rows and columns, such as marks in a table and seating arrangements or a spreadsheet. So for this, we use a 2D array. So this is how we declare the 2D array. So a 2D array is simply an array of arrays. Okay. And then we have methods. So as programs became larger, we don't want to write the same code repeatedly. So this is where methods become useful. So a method is a reusable block of code that performs a specific task. So a method has 3 main parts. So let's take the example int add numbers int a comma int b. So these methods we have discussed in our last lecture. So here int is what is int? So if I write a method, if I start declaring or defining a method, what is this int called? What is this int? Yes, anyone?
Please your question again.
It's used for storing whole numbers.
No,
Integer.
this int, yes, int is integer.
Yeah.
I understand, but what is this called? When you define a method, you have to follow a syntax.
Madam, please, it's like I don't really get the question. Please
The
come again.
quest, see, when you define a method, you're going to perform some action, right? So when you define a method, what is the first thing you have to specify?
A data type.
Yes, data type. So that is, in methods, we say it as return type. Here the int is a return type. The type of value returned. So here I'm trying to add two integers, a and b. So my output will be an integer. So int a comma int b are the parameters, inputs required by the method. So add numbers is a method name. So inside the method, if you see this one. So inside the method, we often use a return statement, a plus b. So here we use a plus b. Okay, so here I'm making this as static. So it's a static method, so you don't need to create the object. You can directly write int total. So whatever the result is, you are going to store it in the variable total. So int total equal to add numbers. That is my method name. And I'm directly giving 5 and 3. So 5 will go to A and 3 will go to B. And my output, that is return 5 plus 3. So total will get 8. The variable total will have the value 8. And system.out.println, you are printing total. So in the output screen, you will get 8. So what is the use of methods? What is the use? What are the benefits? We have already discussed last week. We have learned about methods, how to declare it, and then we learned about static methods, and then we learned about constructors. Yes?
Madam, please, to avoid repetition.
Yes. Avoid repeating the same code. and make programs easier to read, and break large program into smaller manageable tasks. And also it makes testing and debugging easier. So these are the advantages of methods. So a method is a reusable block of code that performs a specific task and can be called whenever needed in a program. So this is very important because we need this in our advanced Java. If you see all the programs, it's based on methods. So without the methods, you cannot write advanced Java program. I'm not talking about the basics core Java. I'm talking about advanced. So you have to practice these methods. And then we have method overloading. So Java allows us to create multiple methods with the same name, provided their parameter lists are different. So this is called method overloading. So the method may differ by number of parameters or the type of parameter. For example, here I have 3 methods. And in these 3 methods, I'm using the same name. See, I'm using add. This is also add, this is also add, and this is also add. But here, if you see the parameter, what is the parameter? First, I'm trying to add 2 integers, a and b. The parameters are integer. And in the second one, I'm adding decimal value, double a and double b. So the parameter is different. The type is different. And in the third one, again, I'm adding integer. But here, the number of parameters are 3. So here I'm adding 3 numbers. So when a method is called, so here we are calling the methods. So when a method is called, Java automatically chooses the correct version based on the arguments provided. For example, first I'm writing add 2, 3. So 2 and 3 are integers. So this calls the method with 2 integers. And then we have 2.5 and 1.5. So this calls the method with 2 doubles. And then we have 1, 2, 3. All are integers. So this calls a method with 3 integers. So the return type alone cannot be used for overloading. So the parameter list must be different for Java to treat it as a new method. So method overloading means using the same method name for similar tasks while changing the parameters to handle different inputs. So these are the basics. So this you have to revise it. Yes. So we have covered the main Java concepts. And now it's time to check your understanding. So please, on the screen, you can see 6 questions covering the basics. Okay. So can you answer it? Why must main be declared static? So which loop always runs its body at least once? And what is the index of the first element in an array? Yes.
Zero.
Yes, that is 0. And then this loop always runs its body at least once. At least once. At least once means you remember the while and do while. In while loop, we are checking the condition first. So if the condition is true, it executes the loop. But if the condition is false, it's not going to execute it. But in do while loop, we are checking the condition at the end. So we write the statement and then we are checking the condition. So what will happen? Even if the condition is false, still the loop executes once. Because the condition we are checking at the end. After executing the body of the loop, we are checking the condition. So the answer is do while loop. So do while loop executes the code first and then checks the condition. So this means the loop body will always run at least once. Yes. And the first question, why must main be declared static? So what happens when a program starts? What happens? Tell me. Yes, anyone.
You declare the main.
Yes, we'll declare. No, I'm talking about the execution. So what happens when a program starts executing? So when you run a Java program, first the JVM loads the class and immediately looks for the main method. So at this point, no object of the class has been created yet. So JVM simply notes, I need to find the main method because main method is a starting.
Okay.
So I'll start executing the program. So if I'm declaring the main method as non-static, I'm not making it, instead of public static void main, I'm writing public void main. So when I write public void main, that becomes a normal method, a normal class method. So to use that method, You need to create the object. Then you need to call it. You need to call the method. But if the main method is not static, the JVM would need to create an object before calling main. So in that situation, what will happen? Which constructor should be called when we write, suppose a class S, student, and I'm creating an object student S equal to new student. But in this case, which constructor should be used? Which class? Which class we can use it? And what value should be passed to the constructor? And how should the object be created? Because everything is depend on the main. See, if you are locking your house, locking your main door, and there is no other way the guest can enter the house, and you have locked it. So can they enter? No. So if you are not declaring your main as static, then program cannot start. Because main is the execution point, it's the entry point where execution begins. So to run the program, JVM needs to call the main. So a static method belongs to the class itself, not to an object. So this means the JVM can call the method directly using the class name. So if you are using a normal method, that is non-static method, you need to create the object. But when you use a static method, it can be used directly through the class. So because main is static, the JVM can start the program immediately without creating any objects.
Okay, madam.
Yes.
So you don't declare the start the main method as static, and you declare an object first. Can the JVM execute?
No, because see, when a program runs, first the JVM is looking for the main method.
Okay.
It's like if you want to enter into the class, first you will look the gate. So if the gate is closed, then you cannot enter. So the same way you are the JVM and the gate is the main. So your JVM cannot start the program because JVM needs a main method.
Okay.
And after executing, when it starts executing, then it can execute the other things like object creation, calling the methods, and everything is the second part. The first part is the main method. And inside the main method, we create the object of the class. We invoke the methods inside the main method. If main method is not executing, it means your program is not executing.
Okay. Well, that's good one.
Yes, any question? Is this clear?
Yes, please.
Okay. And the next question is, yes. So what keyword declares a value that can never change? What is that called?
Constant.
Yes, constant. So we use the keyword final. And then which scanner method reads a whole line of text? So what is the use of scanner method? What is the use? To take the input from the user. So we use the scanner class to read input from the user. So we write Java import java.util.scanner at the top. And inside the main method, we create the scanner object, because scanner is a class. So you have to create an object, scanner is equal to new scanner. So, and there are some methods. We can use next int if you are taking the age of a student as input. Then you can use next int, because age is an integer. And then you can use next double if you want to read a decimal number. So you will write SC, that is object of scanner, dot next double. Or you will write object of scanner, that is SC dot next line. So next line reads a complete line of text. So it reads everything on the line, including the space. So what does method overloading let you do? Yes. What is method overloading? Yes, what is method overloading? Method overloading means creating multiple methods with the same name. The methods may differ by number of parameters or type of parameters. Just now so one example, see this. The method name is same, add, add, add. But the parameters are different. So method overloading means using the same method name for similar tasks while changing the parameter to handle different inputs. So no two method has the same name and same number of parameter or the same type of parameter. Okay, either you have to change the type. So in this example, I'm using int, but I change it to double. Or if you want to use the same int, then you have to increase the number or increase or decrease the number of parameter. Okay. So let's bring everything together. So today we revise the core concept that form the foundation for everything we learn later in the course. So we covered Java fundamentals, operators, then input output, then control structures, arrays, and methods, method overloading. So yes, so programming is not something you learn by only listening to lectures. The real learning happens when you write code, make mistakes, fix them, and practice regularly. Okay. Okay, so whatever we have covered, you just try it. So if I'm saying the main is static and you have to write public, then it's void. So try to change it. See, you have your laptops, you have your IDE installed. So try to change it. What will happen if I'm skipping the static or if I'm not writing it as public? Or instead of void, if I write int or string or any other data type, what will happen? So you write a program, make these changes, and then execute it and see what is happening. So nothing will, your system won't change. Nothing will happen to your system, laptop. You're just practicing it. So you make mistakes. And then you will understand more. So please, this needs practice and revision is very important.
Yes, madam.
If you want, I'll share you more notes. I think I have posted everything on the LMS. So have you resolved your LMS issues?
Yes, madam.
Okay, so you can access the advanced Java materials, right?
Yes, madam.
Okay. Okay, so I have gave you the reference books, course outline, everything. I have uploaded it, and the module notes. So that is very important. And I hope next week we can finish Unit 1 and then move on to the practicals. Okay, so can I continue?
Yes, madam.
Okay. So let me open the slide. Just give me a second.